Field of view, Wikipedia audio. The field of view is the extent of the observable world that is seen at any given moment. In the case of optical instruments or sensors, it is a solid angle through which a detector is sensitive to electromagnetic radiation. In the context of human vision, the term field of view is typically only used in the sense of a restriction to what is visible by external apparatus, like when wearing spectacles or virtual reality goggles. Note that eye movements are allowed in the definition but do not change the field of view. If the analogy of the eye's retina working as a sensor is drawn upon, the corresponding concept in human is the visual field. It is defined as the number of degrees of visual angle during stable fixation of the eyes. Note that eye movements are excluded in the definition. Different animals have different visual fields, depending, among others, on the placement of the eyes. Humans have a slightly over 210-degree forward-facing horizontal arc of their visual field, while some birds have a complete or nearly complete 360-degree visual field. The vertical range of the visual field in humans is around 150 degrees. Humans and animals. The range of visual abilities is not uniform across the visual field, and varies from animal to animal. For example, binocular vision, which is the basis for stereopsis and is important for depth perception, covers 114 degrees of the visual field in humans. The remaining peripheral 40 degrees on each side have no binocular vision. Some birds have a scant 10 or 20 degrees of binocular vision. Similarly, color vision and the ability to perceive shape and motion vary across the visual field. In humans, color vision and form perception are concentrated in the center of the visual field, while motion perception is only slightly reduced in the periphery and thus has a relative advantage there. The physiological basis for that is the much higher concentration of color-sensitive cone cells and color-sensitive parvocellular retinal ganglion cells in the fovea, the central region of the retina, together with a larger representation in the visual cortex in comparison to the higher concentration of color-insensitive rod cells and motion-sensitive magnocellular retinal ganglion cells in the visual periphery, and smaller cortical representation. Since cone cells require considerably brighter light sources to be activated, the result of this distribution is further that peripheral vision is much more sensitive at night relative to foveal vision. Many optical instruments, particularly binoculars or spotting scopes, are advertised with their field of view specified in one of two ways: angular field of view and linear field of view. Angular field of view is typically specified in degrees, while linear field of view is a ratio of lengths. For example, binoculars with a 5.8-degree field of view might be advertised as having a field of view of 102 mm per meter. As long as the FOV is less than about 10 degrees or so, the following approximation formulas allow one to convert between linear and angular field of view. Let A be the angular field of view in degrees. Let m be the linear field of view in millimeters per meter. Then, using the small angle approximation. In machine vision, the lens focal length and image sensor size sets up the fixed relationship between the field of view and the working distance. Field of view is the area of the inspection captured on the camera's imager. The size of the field of view and the size of the camera's imager directly affect the image resolution. Working distance is the distance between the back of the lens and the target object. In remote sensing, the solid angle through which a detector element is sensitive to electromagnetic radiation at any one time is called instantaneous field of view or IFOV. A measure of the spatial resolution of a remote sensing imaging system, it is often expressed as dimensions of visible ground area, for some known sensor altitude. Single pixel IFOV is closely related to concept of resolved pixel size, ground resolved distance, ground sample distance and modulation transfer function. In astronomy, the field of view is usually expressed as an angular area viewed by the instrument, in square degrees, or for higher magnification instruments, in square arc minutes. For reference, the Wide Field Channel on the Advanced Camera for surveys on the Hubble Space Telescope has a field of view of 10 square arc minutes, and the High Resolution Channel of the same instrument has a field of view of 0.15 square arc minutes. Ground-based survey telescopes have much wider fields of view. The photographic plates used by the UK Schmidt telescope had a field of view of 30 square degrees. The 1.8 m Pan-STARRS telescope, with the most advanced digital camera to date, has a field of view of 7 square degrees. In the near-infrared UFCAM on Euclid has a field of view of 0.2 square degrees, and the Vista telescope has a field of view of 0.6 square degrees. Until recently, digital cameras could only cover a small field of view compared to photographic plates, although they beat photographic plates in quantum efficiency, linearity, and dynamic range, as well as being much easier to process. In photography, the field of view is that part of the world that is visible through the camera at a particular position and orientation in space. Objects outside the FOV when the picture is taken are not recorded in the photograph. It is most often expressed as the angular size of the view cone, as an angle of view. For a normal lens, the diagonal field of view can be calculated FOV equals 2 arctan, where f is focal length. The field of view in video games refers to the field of view of the camera looking at the game world, which is dependent on the scaling method used. Conversions: machine vision, remote sensing, astronomy, photography, video games.